So hello guys, welcome back to Coding Bees. Today we will learn about queue data structure in the terms of linked list. So we have already told you the linked list is the train like data structure, means you have seen the train, a railway train, uh, one by one compartments. So the nodes behave like compartments, and it is one by one data structure. So we will learn about the queue and the linked list representation. So here I'm teaching you how, showing you the how you can see this is the node. Suppose the value is 1, data is 1, and pointer first, and it is first pointing towards null. Okay, then when we can when we will insert a new, then we will create a new node, suppose 2, and next null. Okay, so now now you will see how the data structure is, how the data structure of queue represent. Queue means what? A line, means suppose a store is here, store, store, and someone is want to buy something. Okay, so first, the person who came first, like the number 1, will reach to the store first. That is the rule of the queue data structure. So first we will create front here. Okay, front, front, suppose F, and rear, rear. Okay, so first these two, front and rear, both pointing towards null. Okay, okay, first pointing towards null. Wait. Both pointing towards null. Now when we will assign, initiate the queue data structure. Okay, then both the front and rear both point towards the front row. When we enqueue, enqueue, you know what is enqueue? Enqueue means to insert a data. Okay, then when we will insert another one, then only after the first insertion, after the first enqueue, only the rear will move. Okay, so the rear will move towards this position. Pointer is also here, so wait, let me draw it afar, then it will look good. Okay, also the front position also. Mhm. Okay, I will create a front. Okay, and we will create it in a box, and then this is how, this is the how it will look like. Okay, then we will create another box now. Okay, suppose 3, and at last it will point null. Okay, now if we, the rear will move towards where, to the 3. Now if we want to delete this data, this data will delete, wait, z, this data will delete, and the front will go like this. So only if we shift the front to the next position, and the traverse will be like this, from front to the rear. So here now the front will, you have understood the point. Okay, one more thing, if the queue is empty, means both these two are pointing towards null, then dequeue is impossible, means we can't delete any data because the data is not present here. Okay, so data won't be deleted, so the error will show up. And after this data structure, means the linked list representation of queue can't be get fooled because it is a dynamic storage. So unless and until the storage of your computer like SSD is full, the data won't get fooled. So you can insert as many as data you can. So the only condition we will check here, the empty, when is dequeue, and during insertion and deletion of array representation of queue, we have to check both the array is full or is empty, because there we have the predefined number of compartments in the array, and which uh, overcome by linked list. So now we will move toward code. Okay, so first I will describe you the dequeue structure, how the front move towards the next node. Okay. Hmm. 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 Okay, so this is the only data structure how yeah, manage. So now we will move toward the code. Okay, what's the code now? So the code is like this. We are checking the empty first. So we have already created the node data structure and the functions which are going to be used in this. So now we will check the empty data structure. The front is null. If the front is null, means rear is null. Also rear is null. So the it is empty. It will return the boolean structure. Okay. To Enqueue, we will create a new data structure. Then we will check is empty or not. If the empty, then the both is new node, and if it is not, then rear dot next is new node, and rear is equal to rear dot next, like we have already done in this. When we have inserted this, then we moved the rear here. Okay, now we will check the dequeue. I have already mentioned, if the empty, then it will return null, and front dot next is temp is equal to front, and front is equal to front dot next. means during the deletion, and we will return the front. And in this we will go traverse towards from front to rear. And now we will make like choice. Okay, we will create a do while loop to check to execute our program. Interactive execution. Okay, now we have completed our code. So